Welcome to Click My Project. Our project title is Cost Aware Activity Scheduling for Compressive Sleeping Wireless Sensor Networks. Let us see the abstract of our project. In this process is enhancement process of our base paper. In order to collecting the information more efficiently, the wireless sensor network are partitioned into a cluster. The cluster provides an effective way to prolonging the lifetime of wireless sensor networks. In this project, a fuzzy logic based clustering approaches within and extensive to the energy predication has been proposed to prolonging the lifetime of wireless sensor networks by evenly distributing the word routing. The proposed clustering method follows an enhanced optimized energy efficient routing protocol. Here the buffer node is collected all the communication from the source node and sets the destination. The buffer node is used to store all the communication that the details in buffer storage. Then the simulation results shows the proposed approaches is more efficient than other distributed algorithm. Objective of our project: to reducing the energy consumption to increasing the network lifetime. The main objective of our project is efficient cluster formation using a fuzzy logic based clustering algorithm for wireless sensor network. Let us see the flow of our project. In the proposed model, the sensors nodes are considered to be deployed randomly to monitoring the environment continuously. All the sensors nodes are dynamic except the buffer node because the buffer node is static and mobility. Homogeneous network have been considered such that all the sensors nodes have equal energy. The distance between the nodes and the buffer node can be computed based on the receiving signal strength. Finally, through the simulation result, it has been shown the proposed approaches from the better than the least protocol. First one is a network formation. The network formation are formed within a given range of the sensor. Nodes are grouped automatically depend upon the radio waves agent or formed for a group registration. The simulation work has been done with the network simulator NS2. In the simulation, nodes are randomly distributed within the network field of the size of given region. The TCP is used for establishing the connection between the source and the destination. Then the file transfer protocol and the randomly choosing the different source destination connections. Next one is a protocol implementation. Here I implemented the enhanced optimized energy efficient routing protocol. Then the protocol containing the particle swarm optimization. The particle swarm optimization algorithm is used to find each and every node position, velocity, distance and speed of the node. This algorithm is used to updating all the nodes. Then cluster formation. The cluster formation is nothing but it is the position based grouping is done here. Then source and destination is mentioned here. Then neighbor node estimation, and the neighbor node estimation on demand reactive protocol that uses the routing tables with one entry per destination. If the source nodes need to find the route to the destination, it starts a route discovery process based on the flooding to the locate the destination node. Upon the receiving a routing request packet, the intermediate nodes updating their routing table for reverse route to the source. Similarly, the forward routing to the destination is updating upon the reception of the routing replay. Packet originated either by the destination itself or any other intermediate node that has current routing to the destination. Then the secure communication. Here check the communication. If it is the a member of the node communication means it will allow other otherwise it will not allow for a communication. Here security packet is added. Then the performance evaluation. A difference network parameter analysis is being done of the proposed and the existing protocol. Parameters like the total energy consumption, throughput, packet delivery ratio and delay are compared for a proposed and the existing protocol. This is the enhancement process of the base paper. Let us see the output of our project. First, open the terminal window. Then change the directory. So type cd space code. Our directory name is code. So I type cd space code. Now change the directory. Then now I run the network simulation. So type ns space main.tcl. This command is used to run our project. Here I deployed 14 nodes. Then this is an NAMP console. This is an out.namp. The out.namp file is displayed our output screen. This button is rewind button, playback button, stop button, play forward button, fast forward button, then timing. This is a speed. This is zoom in button and this is zoom out button. Now I play the project. The buffer node is created. Position placed, clustering is done. This cluster contain a one source node and this cluster contain one source node and this cluster contain a one source node. The blue color cluster containing a destination node. The buffer moved to the source node, then collected the communication. Now source is created. The source node sends the communication to the buffer via the relay node. The source to buffer communication find the neighbor node based communication. Then the buffer's node move to the another source node. The source node sends communication to the buffer node. Now this source node sends communication to the buffer node. Then it will send communication to the destination node. The routing is based on the EOERP protocol and neighbor discovery algorithm is used to run the routing path. Now I run the graph. Xgraph space pdr.txt command is used to our packet delivery ratio graph. The packet delivery ratio is high when comparing with an existing system. Now I explain the neighbor node. The neighbor node algorithm is used to find each and every node neighbor nodes and that x position and the y position, then distance is calculated. Then particle swarm optimization algorithm is used to display the each and every node position, velocity, speed of the node at a particular millisecond. The energy is updated. Thank you for listening. The demo is completed.